What is reality made of? It's the question that's been asked since the dawn of humankind. We've made countless stories and advanced science to answer that very question. For a better picture of reality, we looked at things up close and discovered entirely new worlds. A world of cells, molecules, and finally, atoms. For a while, that was it. Until we smashed them together really hard and the elementary particles were discovered. We were able to construct a new story, the Standard Model, simplifying the universe into one elegant picture. Smaller than atoms, particles called quarks and leptons make up all matter. Up and down quarks make up protons and neutrons, forming the nuclei of atoms. Their fractional charges sum to give the protons and neutrons their overall charge. Leptons refer to electrons, which are bound to the atomic nuclei. And also neutrinos, the most abundant fundamental particle, which the sun bombards us with every second as it generates neutrinos during nuclear reactions. Each particle also has an antiparticle which annihilates the other when together. These particles are enough to explain most everyday matter. However, smashing lots of particles has revealed that there are mysteriously two heavier versions of each. So the quarks and leptons make up all matter. Me, you, and the device you're watching this video on. But we don't just exist, we do stuff. This is where the bosons come in. They carry the fundamental forces and rule how everything moves and interacts. Just like a game where a number of rules dictate each piece, the fundamental forces guide the particles in the Standard Model. But how does a particle carry a force? They do so by exchange, like how this exchange imparts a force onto me. The fundamental forces are the electromagnetic force, the strong and weak nuclear forces, and gravity. The electromagnetic force binds electrons to atomic nuclei and governs all atomic bonds. Photons are the carriers of the electromagnetic force. The strong nuclear force binds all the charged particles in the atomic nuclei together and is carried by gluons just as the electromagnetic force is by photons. If I pick up a handful of stones, each stone representing a particle in the nucleus, they are held by my hand with a strong force. Some stones will fall out because a strong force cannot hold them all together. This represents decay, governed by the weak nuclear force and carried by the W and Z bosons, which are incredibly massive compared to their massless force-carrying counterparts. Their mass makes them weak, with a tiny range of influence, like comparing the efficacy of a cup of tea and a tea bag at carrying the tea interaction. The final force, gravity, is still unaccounted for because it is so weak compared to the other fundamental forces. Our story is still incomplete. There are still holes in our picture. Unanswered questions such as where does gravity fit and why are there heavier generations of the matter particles still require stories to answer them. Like Stephen Hawking once said, our goal is simple, a complete understanding of the universe.